What's up, everybody? It's Miss Wesley, and I feel like I might know what you're thinking. You're looking for that branch of mathematics that's like the perfect mix of geometry concepts with angles, triangles, circles, and then a bunch of the great algebra that we know and love. You want them to merge, bring in a bunch of new ideas, and have a math that gets you ready for all the concepts you'll see in the math courses to come. And that, my friends, is trigonometry. Here in Algebra 2, we get to do an introduction to it together. And I have a new packet where I'm going to pull some examples from called your Trig Packet, where it says angles and trig functions at the top. I mean, even just look at this warm-up here. It says estimate the measure of the angle. I don't know. Think about it for a second. What would you estimate without pulling out a protractor? What do you think? What do you remember from geometry? Well, I don't know. Would you say kind of angled funny, but maybe like about 30 degrees or so? I'll put the degree sign after it. I'm used to seeing angles kind of, I think about the coordinate plane, an x-axis and a y-axis. It's kind of weird to see this down in what they call quadrants 1, 2, 3, quadrant 4, right? I'm used to seeing stuff up in quadrant 1. If I think back to geometry, I dealt with angles that had measures from 0 all the way up. Here's an acute angle, a right angle, all the way to what degree measure would be a straight angle, 180 degrees. But here, as we move into Algebra 2 and some pre-calculus calculus concepts, we're talking about angles that could be any number of degrees around the circle. A whole rotation, right, would be 360 degrees. And would you believe you can even go beyond that? So technically, there's an infinite amount of ways to estimate this angle measure. You actually might have said, we'll see this below, about negative 30 degrees would be okay. A negative angle measure could happen. You could even say, I want this huge angle past 180 all the way to what they call this terminal side, and it could be around 300 degrees. That'd be another good estimate. So let's talk basics and vocabulary surrounding angles. Speaking of vocabulary, this is a unit on trigonometry, might as well define it. Comes from the Greek, and the word means measurement, which we've just been talking about, of triangles, actually. And triangles will come into play a lot as we introduce ourselves to trigonometry here. And they've got 3 angles. The measures of them total up to 180 degrees. It says basic trig terminology. So we've been talking about angles. An angle is formed by rotating a ray around its endpoint. And I never gave you guys a joke for the day, so I'll put it here. What would you call this drawing? We'll pause for a second. Like that. And I'm going to put C-H-A-R and then L-E-S. What do you think? If I put a little music note here. Aha, it's Ray Charles. So if you took a ray, rotated it around its endpoint, you end up getting an angle. We see an angle here, and you've got some labeling on the 2 sides of it. In its initial position, where you see this horizontal ray coming out from that vertex, that's called the initial side of the angle. What you start with. Okay. And then the ray in its location after you rotate, see this arrow of rotation represents this little acute angle that I'm traveling up, is the terminal side of that angle. The endpoint of the ray is the vertex. And we've seen that vocabulary before too. You've got a vertex point for every angle. I really like an angle that looks like this one or even these. The rotation of a terminal side of the angle, if it's counterclockwise, like this one, this first one, counterclockwise, the angle is going to have a positive measure. So I'm not sure until I pull a protractor out here. I could estimate it maybe around 300 again, but you're going in the positive counterclockwise direction, that amount of degrees if you're measuring it. If the rotation is clockwise, like the second picture here, angle ACB, the angle would have a negative measure. So the angle is considered negative. So that's why up in this picture, when I was estimating maybe 30 degrees here, I don't know, if I draw the arrow of rotation so that it's clockwise, I'm best picking negative 30 degrees if I'm going that way. Now, the reason I like the way these diagrams look is because all these angles are presented in what's called standard position. And that's what we're going to strive as we draw angles and deal with angles in the beginning of this trig unit. We're going to work with angles in standard position, vertex at the origin, initial side always along the positive x-axis for starters, and then the terminal side could be in any which quadrant. And speaking of those quadrants, let's make sure we can number them, right? Quadrant 1 up in the upper right-hand corner. Quadrant 2 is going to be the second one, so you have 1, you have 2. Quadrant 3 is going to be down here, Q3. Negative x and negative y, and then Q4 right around the bottom. So your terminal side could be in any of those 4 quadrants. And another thing we'll see is sometimes these angles of rotation get really big and you're going more than one whole time around the circle. We might see that, definitely going to see that in number 3. I see a big angle measure here. 1, 2, and 3 are just asking you to sketch the angle of standard position. Again, do not reach for a protractor. All I'm looking for is an initial side in the right spot and a terminal side in the correct quadrant. So let's take 36 degrees. Shouldn't be too bad. Can you draw your initial side first? So initial side, vertex at the origin along the positive x-axis. 36 degrees hasn't taken us very far. You'll be in quadrant 1. So you have a quadrant 1 angle. Standard position. How about negative 150 degrees, right? This is new. Start with the same initial side. So positive x-axis sprouting out from that vertex at the origin. Because this angle measures negative, let's go clockwise instead of counterclockwise. And we have to travel 150 degrees. What quadrant is that going to land you in? Well, I guess quadrant 3. You haven't gone quite all the way 180 degrees over to this quadrant line again. You've just missed it by 30 degrees. So you are 150 degrees in the clockwise direction. That would look good for standard position. All right, 450. To me, if I see any angle measure that's above 360, and we'll flesh this out at the bottom of the page here, I'm going to subtract 360 so I get a better picture of where this thing falls. Subtracting 360 from an angle measure, 360 degrees, shouldn't change where the angle falls. It just changes the amount of rotation. So if I take 450 degrees and I subtract 360, I'm down to an angle I'm very familiar with, your right angle of 90 degrees. So here's how the angle will look. Standard position, initial side, where it always is. Terminal side is going to be at 90 degrees. You have a right angle. But here is your arrow of rotation. You went a whole 360 around the circle and 90 more degrees than that. That was probably the most fun spiral to draw because you're going all the way around and then up to the top. Doesn't fall. This is a quadrant 3 angle. This one doesn't fall in any quadrant. It is called actually quadrantal, if you want to write that here. Quadrantal angles. Separate the quadrants. It falls along one of the quadrant lines. Speaking of which, can you name any right now? So 0 degrees is here. Can you name that one? 90 degrees is quadrantal. 180 we've talked about, right on that axis. And then 270 degrees. And by the time you've come back full circle, no pun intended, even though maybe I just intended that, you're back to 360. So let's take some notes on that. A complete rotation of a ray results in an angle measure of 360 degrees. By continuing this rotation, you could have, like in the case of example 3, angles that measure larger than 360. They could be produced. Such angles, so a 60-degree angle and a 420-degree angle. You get that number just by adding 360 to this number here. They fall same initial side, same terminal side, just a different amount of rotation. And they have a special name. They're called coterminal angles. And they become pretty important. This is my, I mean angles here. I'll write that out. And I use that little symbol with the line there too. Coterminal angles look the same, different amounts of rotation, and their measures always multiply by some, or they always differ by some integer multiple of 360 degrees. Check out this second picture. 110 degrees is coterminal with 830. Because if you took 110, you added 360 to it once, right? You would get up to 470. If you add 360 again and maybe again, you're all the way up to 830. And you've landed in the same spot. You're just calling the angle by a different measure. So how do they come into play? Let's skip around on this next page. Can you sketch? I want to do a tough one. Let's sketch an angle of 590 degrees and see if we could follow all of these directions. Again, just in the very last example, I see a number that's bigger than 360. I'm going to subtract 360 to get my bearings. So I'll subtract it, 590 minus 360, and you end up just getting 230 degrees. So I'll put that here, 230 little bit easier to recognize. I want to circle that because that actually is going to turn out to be one of my future answers in this problem. Same thing, initial side has to be on positive x-axis. Terminal side, what quadrant do you think? Well, we just talked about the numbers that split the quadrant lines. 90, 180, 270, we haven't quite gotten there yet. So 230, let's just land it down in quadrant 3. I noticed that part of the directions said, could you name the quadrant that you land in? I'm going to draw an arrow representing the correct amount of rotation. So you went a full 360 and then back down to quadrant 3. There's your arrow of rotation. What else do we have to do? Find the measure of two other angles, one positive and one negative, that are coterminal with the given angle. We just found one of them. Adding or subtracting any whole number multiple of 360 is going to get you something that's coterminal. So we subtracted 360 once, we got 230. If we need a negative coterminal angle, like for some reason we just need one that's lower, you can keep on subtracting 360s till you're blue in the face, because there's an infinite amount of coterminal angles with this original angle that's given. So here's a negative coterminal angle measure, negative 130 degrees. You can see it on the picture. Negative 130, I'll do it in blue just so that nobody thinks it's part of my answer. You're still starting at 0. You're going in the clockwise direction, 130 degrees that way, and it lands you in the exact same spot. Let's try 7. Let's try the one underneath. I'm just interested in these ones with big numbers here. Negative 1,000 degrees. I need to talk to my skater boys in the crowd. I know if I do a full 360, right, that's a pretty cool skating trick. 2 360s would be a 720, and 3 360s would be a 1080. Okay, so can you, adding or subtracting any integer multiple of 360 should land you in the same spot. Could you add 1080 to this? That's just 3 times 360. If I add 1080 to that, that's some quick math to get me 80 degrees. Circle it because it could be one of our answers for later in the question. What quadrant would that fall in? Let's draw this angle. You've got initial side 0 degrees, terminal side not quite to 90. And let's try to draw this original arrow of rotation, negative 1,000 degrees. Well, it's a lot of swirling around. You start at 0. Since it's a negative measure, let's go clockwise instead of counterclockwise. So here goes nothing. 1 360, 2 360s in the negative direction. That's a 720. And then almost another 360, not a full 1080. You're just shy of that. You're 80 degrees shy of that to get that arrow of rotation. So we are in quadrant 1. We'll put that answer. We've got the picture drawn, and we have one positive coterminal angle. I just never, in the in-between, got a negative coterminal angle, and there's many you could choose from. You could take negative 1,000, the original, and add 360 to that, and get one other option for a negative coterminal angle. A negative 640 degree angle would be fine. I don't know why you'd need that. Another answer, you could add 360 to this and get a negative 280 before you've gone all the way. So again, just to emphasize, you have a lot of different answers for these questions. And speaking of which, what it says in 8 and 9 is find an expression, could just cut to the chase, that's going to generate all the angles coterminal with a given angle. Let's do 60 degrees in number 8 as an example. Can you think of it on your own? Can you write a variable expression that would generate all the coterminal angles to 60 degrees? Well, what do we say in English words? We said you can add or subtract any whole number multiple of 360. So I'm going to put plus 360 degrees times n, like that. And this would work. Now, recognize that I said add or subtract, but watch what I put after this. I'm going to say where n is an integer. We got to think back to what an integer means too. Integers are all positive, negative whole numbers and 0. Negative 2, negative 1, 0, 1, 2, 3, 4, and so on. So that covers the whole. I mean, you could have put a plus or minus here, but if we're calling n an integer, that means we can add or subtract any multiple of 360. Okay, stay tuned for the next part.